Okay, statistical functions as in your mean, median, mode, standard deviation, and variance. Mean, we all know it's nothing but the average. Okay. What is it that we have to do here is mean is nothing but average, again mentioning. Now here I do have, of course, the entire data set is sum of millions record. I don't have that record. A small portion of the actual record, which is nothing but NBA players statistics is being given. Their name, biography as to where they belong, born, some few lines about that person. Okay, basketball only, NBA, and which team they are playing for, at which position, age, and few more. You're saying good lot of things that will maybe used to which position, which how many points they have scored for game for per game and all. Lots of things are there, but the main focus from this data set is all about age here. Why age is every other event, games event like Olympics or Paralympics or maybe this NBA on any other one, maybe French Open, the tennis I'm talking about. Any other event happens now, everyone wants to know, like especially in analysis areas, what is the mean age or the average age of the participants. Okay, apart from maybe what's their like height, weight, their BMI. Okay, all of them, those points will definitely be into consideration. But many of the time, the first thing that anyone wants to really analyze or get to know the details about is the age of the participants. So it will just we'll have an idea as to okay, what is the average age of the participants. So over here, if I want to know the average age means that is the mean age means obviously I have to find out the mean only. You can say it's nothing but the average of E2 to E30 because E column is having my age. Okay. That's your mean or arithmetic mean or even average. Okay, see here, arithmetic mean, you can even say it as mean. The function is obviously the average. Okay, now apart from this, you have got your mean and median and mode. Median is nothing but the middlemost value in a range. Okay, say 1 minute. Okay. So I've got 13 values over here, 1 to 13. If I have to find out the median value, the middlemost value, what will first come to your mind? How will you find out? Are you all there hearing me?
Yes, ma'am.
If you feel 13 is a big value, I'll reduce it to 10. 10 is of course the even one. Maybe I'll reduce one more. 9 values are there. How will you really find out what is the middlemost value? Just give it a go. It might be wrong also. Never mind. Just we're learning, no? It's okay.
Number of values divide by 2 and get the middle position, ma'am. Is that true?
Come again, ma?
So the total number of values divided by 2, can I get the middle position?
Total number of
Like
values
if
over here is 9, ma.
9, so
9
yes,
divided
ma'am.
by 2 is what? 4.5.
4.5.
Do I have that?
No, ma'am.
Value
Ma'am,
among
we have
the
to
One
sum up.
divided by 2.
We have
one more I heard something divided by 2. Come again.
N plus 1. Number of value plus 1 divided by 2.
Correct. Correct. That is 10 by 2 is 5. That's what is a middlemost value. And yes, Manoj, you are also right. Okay, how did we arrive at this is the logic says if the number of values or the count of values is even, then it is just directly that number n by 2. Okay, n is the total number of values. But if the n is an odd value, then you should do it like n plus 1 by 2. Okay, so here it's your odd now. So odd will be, odd is 9. 9 plus 1 by 2 is, sorry, my mistake, 10. Or I'll say 9 plus 1 divided by 2. Hey, how it is coming. Okay. But say, suppose the same thing if I introduce 10 over here. You will say the same. Won't it be 5.5 now?
No, ma'am, it is n by 2.
Okay. But is it the middlemost value, ma? Harini? It's not. Okay. Don't worry. We'll come to get to know our median direct. There is a function also. No? Let's see by that also. If what I'm saying is right or wrong, let's find out. Returns the median or the number in the middle of the set of given numbers. It is something like you put a line over here. Say I insert a line over here. On top of the line, exact number of values. On below the line, exact number of values. We say middlemost. Sometime back, Zubeda also told it was 9 by 2, 4.5. We don't have to find out something like 4.5. It won't be required at that time. How I'm saying is, if I delete this, by default it's coming as 5. It'll be like somewhere here. You should choose a value such a way. Why do we say middlemost? Middle is something on top of that, or maybe before that value and after that value. Exact number of values should be there. Like on top of 5, exactly 4. Below 5 also 4, exactly 4. If I add one more 10, I need not be at something like here. I can just come here in between. Below the line 5, above the line 5. That's what even the function, the ready-made customized function, predefined function or built-in function, whatever function is being given by Excel, the median function that also says the same thing. But yes, for your understanding, I did ask you the manual way, which was if it is your even, then it is n by 2. And if it is a odd, n plus 1 by 2. Okay. Not that exactly you should have a value from the range. Logic is your value should, the median value is nothing but the middlemost value. So if I come here to the data set that we are really discussing, it says 30 is the middlemost age in that whole age distribution. If at all we are plotting each and every person's age onto a chart, the age, median age or the middlemost age is nothing but 30. Okay, any doubt?
No, ma'am.
Okay. What about mode? Mode is nothing but a frequently occurring value in a range of values. Say I'll come here. Okay, I'll just select the whole age values here. I'll come up, paste it. I'll of course sort it. I want to sort. I can see each, some of them, few ages are repeating. Like here 25, it's occurring 2 times. 28 is occurring 4. 29 also 4. 5, 2, 2, yeah. So if somebody asks us what's the maximum occurring number, I should say 31. I will get to see the same thing with the help of mode, the last one, okay? If I open it, it will also say the same thing. Returns the most frequently occurring or repetitive value in a array or range of data. Obviously on numbers only it's going to be applicable. That's what it even says here. The number 1, the argument over here, number 1, number 2 are 1 to 255 numbers or names, arrays, or references that contains numbers for which you want the mode. Okay. All good?
Yes, ma'am.
Just give me a moment. I'm getting a call. Just give me a moment. Yes. So mean, median, mode. First 3 of our statistical functions. Next 2 are nothing but variance and standard deviation. Now, in order to come to that formula, like the function, of course I'm going to show you. But before the function, let me come up with a small story of it, okay? Which will definitely help us out to understand how to really go about a variance or standard deviation. You all are able to hear me now? I just unmuted the mic.
Yeah.
Okay. Now variance is how far each number is from every other number in a data set. Now just like you have some 10 to 15 numbers, if you are going to plot it onto a graph, okay, the way the distribution is coming up, variance is just going to tell us what is the difference between each number in that whole distribution. Maybe what I'm telling you now might not make so much sense to you, but never mind, I'll show you up something. Okay, I've got 2 imaginary countries. We have known Uganda and France. Na? Just not to have the same names, I've just changed names to Uganda and France. And the also assuming that this imaginary country is just having 8 as its population. Okay, although not possible, but just as an example for us to understand. and their yearly income is also given. Don't think 71 means the person Nishit is just going to get 71 rupees or dollars. It's actually 71,000. Okay. So 62,000, 66,000, like that. I'm going to plot these yearly income onto the graph. So let me take up this. Pardon me if the line is not so clear, straight and all. Okay, adjust. Okay, or I'll go with A. Yeah. This is your 0 value. This is your 100. And somewhere in the middle, it's going to be 50. Okay. Now, first value is 71. And don't bother the range, the exact value I'm not plotting. We need to understand the concept. That's why. So 71 means somewhat here. I'll just put the value somewhat here. Okay. Next value 62. Okay. Somewhere in the middle between these two, I'll put as 62. Okay. Then 66. Just a moment. Just a moment. Coming. Yes. Sorry, my son just came in. He had gone out, so just came in. Okay. So 62 was the. Sorry, ma. I didn't hear.
No issues. I said no problem, ma'am. It's okay.
Acha, okay. He had just gone out to play with his class friend. That's why, classmate. So, okay, 62 is the next value. Next, gone for 66. So, again, in between these two, I'm going to pick up now. Then comes 61 again. Uh, 54. Oh, horrible. I have to plot everything nearby. Okay, then 67. $55. Okay. 60 is the last. 60 should be somewhere here. Yeah, so 8 points, did it come 8 or 9? No, 8. 50 was not included, so rest 8 we have plotted. But this is for our Juganda. Let's find out for our crans. After we plot in all the, we draw in all the points now, you will understand one main basic thing. Okay, I'm not going to put it as 0 and 100, very much inclusive. Okay, understood. 99, or maybe it's okay. What a big deal. I'll put it, not a big deal. 0, 100, 50. Of course, the first value was 99. So 99, 14, somewhere here. 75. Okay.
84.
Thank you. I understand
And
that.
44.
Okay, that's really nice. Thank you, Ma. Next. Next value.
I'm 2 members on the
54.
and 98.
Right. 54, then 98,
28, 28.
98 and 28 is 14's double. So I'll put it here. Okay. Yeah, it's visible. Okay, fine. Now, why did I plot this? Don't think Maitri has gone crack. She's plotting it. No. Just by seeing this distribution, we can make out that for Uganda, the yearly income are really surrounding or clustering over, very much nearby. I can say 62 is the mean value, although values are different for each one of them. Both these countries, the individual values are different, but the mean value is the same. Is it not something magic? Not only that, I can one more by seeing this distribution, I can say for Uganda, the yearly income are very much near to 62. But I cannot say that in case of crowns. In crowns, the values are all scattered. You have a very low value like 14. You have a very high value like 99. Here, the data points are cluttered or clustered. Here, the data points are scattered. Here, the differences between each data point, individual differences between each data point, the difference is very less. Here, the difference is more. Can I say all these for these two countries? Whatever I told you?
Yes, ma'am.
The mere understanding of this is going to tell us what is variance. Now, variance is nothing but the differences between each value. Like see here, variance is how far each number is from every other number in a data set. But how far here we cannot say something is far. It's all less. Here it's only far. So variance is how far. When the differences are less, variance is also less. When the differences are really high or more, or I can say the data points are far apart, my variance is also more. This distribution is going to tell us how the variance is going to be. Lesser the variance means the points will be very much cluttered, one very much nearer to one another. And when I say the variance is high, the points are going to be very much far apart. Okay? So read it again. Variance is how far each number is from every other number in a data set. Okay? Clear till here?
Yes, ma'am.
If you want me to repeat, I'll do so.
Yeah, you can repeat me. I can't understand.
Which part you want me to repeat, ma?
The variance, fair is spot variance more இருந்தா okay ma'am. Fair variance less இருந்தா என்ன சொல்றீங்க அப்படின்ட்டு புரியுது.
See, what is variance? If somebody is going to ask you, na, it's how far each number is from every other number in the data set. Basically, if there are say 10 points, means what is the differences between among them? Okay. If the points are very much nearer one among, see here, na, can you make out this? They are just surrounding one nearby, like maximum value is like minimum value is how much? 54 here, and maximum value is 71. The minimum value and maximum value, that difference is lesser compared to this. Here it's 54 and 71. Here it's 14 and 99. So can we say the difference is from here like this only? We need not even think about individual value. Just think about the largest value and the smallest value. That difference also gives us an idea. Yes, ma?
Yeah, மேம். இப்ப 2 சொல்லிருக்கீங்களா மேம்? இதுல எது வேரியன்ஸ்ன்னு சொல்ல வரீங்க மேம்? அதாவது ஸ்மால் நம்பர்ல இருந்து
This
லார்ஜ்
difference
நம்பர்.
itself is variance. This difference itself is variance.
ஓகே.
Difference can
Okay.
be lesser, it can be more. When the difference is lesser, variance is lesser. Variance at actual value also will be less. When the
Okay,
difference
ma'am.
is more, variance will be more. The difference itself is the variance, ma'am.
Okay, ma'am. Thank you.
Got it?
Yeah, ma'am.
Okay. Don't mind, I'll say something, ma. When we are in the class, don't use the local language. Maybe others, we don't know how many of you, how many of the others are going to know Tamil. You know Tamil, fine. I know Tamil, I can respond to you, but not in class. If you want to ask something in class, please be it in the common language. After the class or somewhere offline, you can talk in local. Okay?
Okay, ma'am.
Don't worry how much perfect you're talking about in English. Okay? Don't worry about that. And seriously, don't think like who is going to judge you. You know English better, you don't know. Doesn't matter. Okay, so shall we move on?
Yes, ma'am.
Okay, so this is something called definition. We are still understood. Then what is the concept behind it is fine. Now we should understand how to calculate it also. There are two ways of doing it. One is obviously the roundabout way, like which is your manual one, which I can say maybe we would have done in our maths class in our childhood. Okay, we would have learned about it in our statistics classes. That one way I'll show you. Another way, obviously, it's an Excel class. We do have an Excel function for calculating variance. Both of it will come. Obviously, first will come for the roundabout way, which is our maths one. Okay, here I have written the formula for it. Okay, this is your individual value xi minus x bar is nothing but the mean value, average value. Okay, it's very much written here. See, xi is each value in the data set. Average is this. So first the difference is square it up, divided by total number of points. And yes, you have a summation. The squared values you're going to sum up, then divide by the total data points. If you don't understand this formula, no issues. You're just going to learn how this is even coming up. Okay, you have your individual values. Both of these countries, the population is 8. Mean value is 62 for both of them. Okay, first we are to find out the individual income and mean difference. I've written here income minus mean. So 71 minus 62. That 62 is available in B15. Okay, the cell reference is B15. I had given it a customized name, a name range, Uganda mean, just for our easier enough to make the calculations much easier for us. So here B7, 71 minus 62 is 9. B8 minus Uganda mean. Likewise, I am finding the differences, individual differences and means, individual values and mean value difference I am finding here. Now, while we are doing it, you are seeing there are few negative values also coming up, which means few values are more than the mean, few values are less than the mean. So obviously the negative value is coming in. Now, my next job is to cancel the effect of this negative value. And I can do that only when you multiply it, like you just find out the square of these all differences. Because negative and negative is a plus. In maths, see, if one is negative, the result is going to be negative. But if you want to cancel the effect of negative sign or the negative one means you have to multiply again with a negative. Only then the negative is going off. Negative and negative come off to positive. So just to remove that effect, we are squaring it up. 9 square 81, 0, 0, 4 square 16. Now minus 1 square is going to be 1. That 1 minus 1, that minus effect sign is gone. Minus 8 square 64. Likewise, we are just finding out the square. So first we found out the difference, individual value and mean value difference. Then we are squaring it up. Okay, next job. These are your squared values. I am going to sum up these squared values. You can see here 240 is nothing but D7 to D14. 240 is the actual value. That is, squared values I have summed them up to get 240. So first individual value minus the mean value, each individual value, then squaring it up, then summing the squared values. After you do the summation, this sigma is nothing but a summation. In statistics is a summation, for the sigma sign means summation. Last of it is you're going to divide by the total data points. Over here, total data points is 8. 8. I've just applied count. So 240 by 8 is 30. 30 is nothing but the variance. Same way you can do for crans also. It will be like, say I give this name as crans mean. I start off with 99 minus crans mean. Again, I'm seeing lots of minuses are coming up. We are going to do the squares. Okay. We are going to sum them up. And then this value divided by 8. 895.5, 895.75. That is the variance. So compared to Uganda, this is more. Okay, ideally this is not more. 895. Okay, I'll make it as 896. Okay, I'm rounding up to 0 decimal places, 896. But compared to 30, 896 is certainly a big value. Yes? In short, distribution is like the data points are very much distributed, or they are scattered, or the differences between the data points is really huge or more, which tells me variance is also more, because the difference itself is the variance. And here, Uganda, you are getting the variance to be 30. All the individual points, the difference is very less. They are all cluttered or clustered around a single point. So cluttering means difference is less. In return, variance is also less, because variance is nothing but the difference. For here, for Uganda, the variance is less, 30, compared to the variance of crowns, which is 896. This we have found out by the mathematical formula, the statistical formula, which is this. I am teaching you this so that you just don't blindly apply the variance formula or function. If you understand the concept, If you are given some tricky question also, or some tricky requirement, you will at least understand what's going on. It will that understanding is going to help you out a lot. So till here, is it okay or not?
Okay, ma'am.
Okay, ma'am.
Okay. Next is standard deviation is nothing but square root of variance. Okay, before going there, we have seen the roundabout way, like your mathematical way. Na? What is the function? The built-in function from Excel for variance is VAR dot P. One more is also there, VAR dot S. Now, P is nothing but population, which is considering all the data points. Dot S means sample. Sample means it is like one subset of that entire population. Okay. Why the two variants, like two variations are given? Like I'll open the effects, you can see it. Calculates variance based on entire population, ignores logical values and text in the population. Now, many a times this variance, it's been like when the census is being conducted, many of the times they want to know what is the something like a literacy rate and all they want to know. Na? They have that entire population's value in front of them in the Excel sheet. Definitely many a million values are going to be there. Million values are there. Now variance.p, if we're going to apply that million values, the calculation time is definitely going to be longer. What I can do is I can pick up a sample of that entire population and apply variance on them. That sample value or like say out of that million, maybe I pick up just say some 10,000 values. Okay, I pick up some 10,000. That 10,000 is a representative of that entire population. I can apply a variance on that 10,000 also, which will be variance.s. Now, for few seconds, I mean, obviously, the variance calculation time on that sample value is definitely going to be lesser than when you apply the variance.p. Okay, both of them are going to do the same job. Only that one is going to be applied on the entire population and one is going to be applied on the sample of that population. Okay, many a times the values are going to be very much nearer only. Okay, they won't be too much of fluctuation. Maybe, but then this variance.s when you're applying, we are not sure as to on what sample of that entire population Excel is choosing. Some random values it might choose. So we don't have an idea of which values it's really choosing. So the variance.p and variance.s, the results may or may not be very much closer enough. Okay, it might happen. Quite obvious also. But then it all depends what's the requirement. Like if the requirement is more on focusing on the population variance, we have to use the variance.p, even ignoring the calculation time. But if the value is not of so much relevance and if the requirement is going to be satisfied based on the sample value itself, then yes, your job is going to be easier. You can just apply it on variance.s on your sample one only. Okay. I just change it to see you have got variance.s also here. See, slight difference you are really seeing. Although the same number of value only we are applying, no point in .p or .s for it. It is going to be that say 8 only, na? 8 values only we are going to find out the variance. But then even after that, my variance.p and s are slightly different, although not a big difference. If it was on p.p it was 30, .s it is coming as 34. If you see here, see, estimates variance based on sample, ignores logical values and text in the sample. Okay, clear? Now, those are the built-in functions from Excellent. Then I told you your standard deviation is nothing but the square root of your variance. You can apply square root. You can just open the square calculator and apply the square root. You will get your standard deviation. But yes, again, you do have your two variations, the two built-in functions. STD, standard deviation. ST is for standard, DEV is for deviation. STDEV dot P, again, population. Same way, STD dot S. You do have one more for another sample. See, there's a slight difference between the two. What was the previous one? I guess something else was there. 1 minute. This is 5.85. Still, this is even more, very much closer. Compared to variance, it's even more closer. One is 7.47, another is 7.85. All good till here? And
Yes, ma'am.
we have just calculated those values, standard deviation or variance values we have calculated. If we want to understand the overall picture, it is like on average, the person's income is 5,500. It was like, what was this? Is this P or S? P only now. If we like one decimal place, if we round it out, it will be 5.5. And I told you all, it's all $10,000. No? So 5.5 into 10,000 is 5,500. So on an average, person's income is 5,500 plus minus for the mean. Mean value is 62. So the differences of each value from the mean is not very large. It's just 5,500 plus minus, like it can go something like from 5.5 to maybe 10 also, like that. Why I'm saying? Because we do have a 9 also. Even after that, the differences are not going to be huge enough. But over here, the person's income is 30,000 plus, because 29.9, it's almost roundabout to, like, it's almost nearer to 30. So 30,000 plus minus from the mean. Okay. Because average and standard deviation, it need not be the same at every other time. Okay. We have a very large population, obviously in millions now. If that same function is being calculated a good number of times, if you repeat it, like if you have several iterations, every other time you will find a different value. Okay, those are sampling, those are statistical values, something, that's what it even says, estimates. It never tells, it calculates. You remember when I showed you here, it told, okay, it says calculates, but when you go for S, what I told is very much applicable for S, not for P, sorry. When I come here, it says estimates, but for P, it holds calculates. P, okay, at least we'll say the population is going to be fixed. But sampling, that sample one, Excel will keep on picking up random values, like different sample at every other iteration. So you are going to get a different value. Although here it's going to be the same, because number of values is just mere 8. Doesn't matter if it's a P or S. Okay. Now, after seeing all of this, I'm going to read this out for you. Listen with calm mind what it is. Variance is a measure of how spread a distribution is, whether it is cluttered or it is scattered. Clutter means something like this. Scattered means like this. So variance is a measure of how spread out a distribution is, whether all the points are very much nearer, closer to one another, or whether all the points are very much distributed far apart from one another. Okay, it is calculated as the average of square differences from the mean. See, differences from the mean differences from the mean, squaring it up, and then finding out the average. Average is what? The squared values total divided by that n. That's what is your average. So average of the square differences from the mean. That's what is your variance. Smaller the variance, less spread out the data is. Conversely, larger the variance, the more spread out the data is. Someone asked a doubt. Someone asked me to repeat it now. Are you able to understand this now? Sorry, I didn't see who was it. Of course, a lady's voice. Can you speak out, ma?
Yeah, ma'am.
Who are you? I'm just scrolling to the side. Good name, ma?
Pavitra.
Pavitra. So, are you clear on this now? Smaller the variance, less spread out the data is. Like they are very much closer to one another. Conversely, the larger the variance, more spread out the data is.
Yeah, ma'am. That time,
Somewhat clear?
yeah,
Then
ma'am.
that
I'm
time.
clear to that. Yeah.
Okay. Third one over here. Standard deviation is a measure of amount of variation or dispersion of a set of values. If you just think out for a second, variance and standard deviation on the same level kind of thing only. You're seeing the definition is quite the same because standard deviation nothing but square root of variance. The standard deviation is a measure of amount of variation or dispersion, how much they are spread out, how much they are varied, how much they are spread out. The distribution is all about. And it's calculated as a square root of the variance. Now, smaller the standard deviation, closer the data points are to the mean. Conversely, the larger the standard deviation, more spread out the data points are. And yes, the real-time examples are stock market volatility is the best use case for variance in standard deviation. Now, stock market, if anyone is really quite fond of following it every other day, means maybe just pick up two stocks. It could be like once, say for a 1 week, 1 week time, you closely watch the stock. When I say watch the stock means keep a note of what's the opening value, stock value, what is the ending stock value for each of the both the stocks. Make a point, make a note of the stock values, opening and ending value for all 7 days. Or maybe I'll say 5 days because Saturday, Sunday, no stock market. Let's say 5 days. Now, it may happen that one stock is more or less the values are very much similar. Maybe just 1 or 2 points of difference, it's just differed. What about one more stock that we are trying to analyze? It may have one day it can be too high, one day it can be too low. Okay, when we say too high and too low, it's something like it's fluctuating very badly. Okay, but the other one which I'm saying it's not changes, there's no much changes on day-to-day stock values. It's more or less I can say the stock value is really stable. I can say for that particular stock. So the one which is stable, the variance in standard deviation will be lesser because the values are very much closer to one another or they are very much nearer to one another. But the stock which has the values very much fluctuating, like one high, the other day it's too low, something like very fluctuation is really happening, means we can say very well that the variance is going to be higher because the values are really, individual values are very far apart. They're going to be very much distributed. Okay? That's all about variance and standard deviation. Okay. Do you have energy to learn about offset or you want to show me tomorrow?
Tomorrow, ma'am, we'll go through this once again, ma'am.
Okay, no problem. I just got one response. What about the rest? Rest of you feel the same? Or if anyone wants to learn it today?
Same for me, ma'am.
Tomorrow. I've heard from 2 persons. What about 14 other? It's currently there are 17 online, leaving me 16. 2 have replied, 14 are left out. What is the, do you want to learn tomorrow, today?
Anything is fine, ma'am.
Yes, ma'am. For me, to anything is fine.
It's like something too contradictory. Okay. 2
No,
votes for
ma'am.
this, 2 for that.
Say,
Okay, I understand. It's okay. Somebody is typing. Devadarshini is typing. Okay, in that case, I'll do one thing. I'll give a brief on what is offset. Maybe we'll get into the details tomorrow. Okay? That is better?
Yeah, okay, ma'am.
yes, ma'am.
Okay. Now, offset. Let me open one and talk about it. See here, the data that is nothing but month-wise. So 12 months sales is being given for 2 regions, East and West. Now, offset, how can you apply here? What is the purposes of it also? Offset is going to return a reference to a range, that is the given number of rows and columns from a given reference. Now, say you have a starting cell reference. When I say starting cell reference, means a certain value is there, that's starting value. From that starting cell reference, we are going to traverse certain number of rows and columns and then arrive at a destination. Now, destination can be a single cell, it can be more than one cell. Of course, there are rules to it. How we are going to see it? There are almost 5 arguments you can see over here. I'll just say this and then we can stop maybe. Now, reference, first one here, reference, the starting cell reference is A2. A2 is having month as the value. From there, I'm going to traverse 3 rows. January, February, March, 3 rows. And rows, it's a positive 3. We are going to traverse top to bottom, which means my rows and columns both can be negative as well. Okay, as of now, it's a positive 1. So 1, 2, 3, we come to March. Then we are going to traverse 2 columns. Columns are positive means it will be from left to right. So from March, it will be 648 and then 1034. Then you have 2 more arguments. They are optional, of course. But the first one says as height and second was width. What is this height? Height is the number of rows that you want the result to be. Okay? When I said from the starting cell reference, you traverse a certain number of rows and columns, you reach a destination. Now, I told that the destination could be a single cell or more than one cell. Now, that is being decided by this height and width. Height is nothing but the number of rows. If you say number of row, height is 1 means now just row 1. Leave a number of, only 1 row is involved. When you're, what about width? Width is number of columns that you want the result to be. Now height, width, weight, height 1 and width 1 means the cell reference is just 1. When I say height 1 and width 2 means 1 row, 2 columns. It will be, see, just for 1 second. This, if I say F2, 1 row, 1 column, single cell. Height is 1, 2 columns, so width is 2. two rows or two cells together. I may have two cells like this also. It will be but two rows, which means height is equal to 2, and columns only 1, which means width is equal to 1. Okay. Height is number of rows, columns is number of columns. Width is number of columns. So here I want the resultant cell, number of rows and number of columns, or in turn height and width to be 1, which means just single value is what we are going to return. And of course, by the traverse from that A2, which was month, we traverse 3 rows, we traverse 2 columns, we are returning to 1034 is our answer. Okay. Only the last 2 are optional. In case, okay, I'm saying it's optional, but say suppose I am not going to mention and say maybe by mistake, by intentionally or somehow, those last two arguments we are not mentioning. Since it's an optional, we are not mentioning, say suppose. What would happen in that case? The function is going to assume the height and width of the starting cell reference. Starting cell reference A2, height and width is 1. So say if I don't mention these two, I'll still get the answer as 1034 because my height and width of A2, the starting cell reference is 1. Both of them are 1. Clear?
So the
That's
offset is
repeat again.
ma'am. So the offset is something which gives us the values we traverse and gives. Will it give the last value, ma'am?
Yes, whatever is the destination value it's going to provide me. Now the destination can be a single cell or more than one cell, ma. That is decided by that height and width.
Okay, okay. If you give 2, then it will give the maybe last
Correct.
2 values, right?
Correct, but value should be available. Such value should be available, na?
Yes, ma'am. Yes.
There are more examples to this. I'll show you. If you want, I can show you now, no issues. What is it that you want to do?
No, ma'am. Last 2 values you gave as 1, 1. No, ma'am. Give it as 2, 2, and we just want to see how it comes out, ma'am. If you can.
It will show me a spill error. No. See, when I'm here, na, it is not getting enough area to spill out. Spill out means when the return value is more than 1. Because traditional Excel formulas always return 1 value. But from 2021, the spilling concept or the spilling feature was very much introduced in Excel, due to which you can return more than 1 value. Now you want to see more than 1 value return, na? I will give you an idea, ma. I'll do one thing. Columns, rows, we are traversing 3, all good. But number of columns that we are going to traverse, I'm just going to restrict to 1, not 2. When I say 1 means I'll come to 648. Now, I want to say, suppose I want to return both 648 and 1034. What should I do? My height should be 1. My width should be 2. Now I'll get it. It's just 2 values. It doesn't coincide with this. Why the spill error was coming up is it didn't get enough area to spill up. Spill is expansion for your understanding. If you want to write the same for function, one more area here, if I put if I put all 2, it might give me got it, ma? It gave me this value, it gave me this value, and 2 more. There is no value, so 0, 0.
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
but I did come with something which was available with us. Things become more easy. That spilling concept, or that spilling nature of the formulas or functions, was very much introduced from 2021, not before that. And yes, due to that nature, the Excel functions were returning us more than one values. Okay, something different from the traditional functions. Traditional functions will always return only one value.